Hello and welcome. I'm Saeed from storyplanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the book Ignorance, a creation by Stuart Firestein. Ignorance examines the scientific method's pros and cons, emphasizing the value of posing well-thought-out questions rather than just uncovering basic facts. Through historical instances, it demonstrates that recognizing our own ignorance propels scientific advancement. Before we delve into these revelations, it's interesting to note that Stuart Firestein, the head of Columbia University's biology department, researches the mammalian olfactory system in his laboratory. In 2011, he was honored with the Lenfest Distinguished Columbia Faculty Award for his outstanding work in teaching and scholarship. With 8 key ideas to unveil, brace yourself for a deep dive into this captivating book. On storyplanet.net. To start, importance of asking the right questions for personal benefit and progress. The text emphasizes the importance of recognizing our ignorance and asking the right questions to drive scientific discovery. It highlights how gaps in knowledge have led to major scientific breakthroughs shaping our world. It addresses the limits of the scientific method and explores how embracing ignorance can spark new discoveries. It provides examples of how scientists have utilized gaps in knowledge to make significant theories and advancements. Ultimately, it aims to show how acknowledging ignorance can be a powerful tool for progress. Key idea number 1. Science, perceived as objective truth, is created by fallible human beings. Scientific facts are not absolute truths, but rather the imperfect products of human beings. Scientists, being human, are inherently biased, which can influence their conclusions. The positivist view of the world relies on empirical observation and logic, assuming clear cause and effect relationships, although this isn't always the case. Scientists are limited by their own faculties and may not uncover all aspects of reality due to inherent limitations. Scientific discovery should not be seen as a definitive end due to these constraints. Key idea number 2. Scientists sometimes make inaccurate predictions about the future due to a desire to forecast outcomes. Scientists make predictions using the scientific method by observing and developing general rules. These rules help predict outcomes accurately. For example, studying DNA sequences allows predictions, like identifying red hair. Predictions about the future can be challenging. To make them relevant, scientists can ask questions instead of making definitive statements. Daniel Hilbert's approach of formulating mathematical questions in 1900 remained relevant and important throughout the following century. Key idea number 3. Asking questions is crucial for making scientific discoveries by addressing ignorance. Scientific inquiry often begins with ignorance rather than knowledge. There are 2 types of ignorance: willful ignorance and the absence of insight or facts. Embracing the latter can drive scientific progress by sparking questions and inspiring new research. Various fields benefit from uncovering ignorance, like leadership and neurobiology. Embracing ignorance can lead to valuable discoveries and insights, encouraging scientists to tackle big questions and not get sidetracked by biased results. Key idea number 4. Breaking down big research questions into specific, smaller questions aids in achieving answers gradually. Progress in science is made by breaking down big questions into smaller, more manageable ones. This process often starts with writing grant proposals, which outline research questions and data collection methods. By focusing on smaller questions, scientists can eventually address larger issues. Using model systems, such as rats or mice, helps in tackling complex topics like understanding the brain. This approach of tackling small questions to answer big ones is foundational in modern science. Key idea number 5. Scientists discovered insights into animal cognition by studying ignorance. Clever Hans, a horse believed to be capable of solving arithmetic problems, was later revealed to be interpreting cues from his owner's body language. This case highlighted questions about animal cognition. Studies show glimpses of animal cognition through behavioral observations, such as dolphins showing disapproval by distancing themselves when trained incorrectly, or chimpanzees displaying self-awareness in mirror tests. Key idea number 6. String theory was developed due to gaps in knowledge within physics. Physics delves into mysteries from the universe's creation to subatomic particles, but faces a gap in merging quantum and classical laws. String theory, proposed by Brian Greene, suggests energy filaments called strings create particles and can bridge this gap by combining quantum and classical physics through the vibration of strings. Though theoretical, it aims to unify universal behavior as research continues. Key idea number 7. New insights into memory were discovered due to a knowledge gap in neuroscience. Participants in a study accurately identified images they had seen before, revealing that the brain is adept at remembering. Neuroscientists discovered that although our brains have limited synapses, we can still store vast amounts of information by overwriting old memories with new ones. Ignorance was embraced by researchers as a starting point to uncover how the brain functions. It was revealed that forgetting old information is crucial for learning new things and forming important memories. This process allows us to adapt to new experiences and gain valuable insights into brain function. Key idea number 8. Scientists should promote a culture of curiosity by inspiring teachers and students to welcome ignorance and ask questions. The text emphasizes the importance of embracing ignorance in science. It highlights the value of making the research process more transparent and accessible to the public. It discusses how Galileo's decision to publish in Italian opened up scientific knowledge to a wider audience. It calls for scientists to speak openly about their unanswered questions to improve public understanding of science. The text also stresses the need for education to focus on teaching students how to ask the right questions rather than just memorizing facts, especially in the age of easily accessible information. In conclusion, the main point of the book is that scientific inquiry involves asking the right questions more than finding facts. Embracing ignorance is key to asking crucial questions and furthering knowledge. A recommended read is In Pursuit of the Unknown by Stuart, which delves into the impact of famous equations in math and physics history and their societal influence. The book provides a history of scientific discovery with lively examples and anecdotes. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.